So we have to know about the KEGG pathway, Kyoto Encyclopedia for Genes and Genomes pathway. For this purpose, first we have to extract the information from this pathway, and the information can be extracted by using the command GET parenthesis. And if we assume that we are using the chipset that is for Affymetrix and for human HGU133A, so we can easily get the information by using the command GET parenthesis. And after getting the information, we can save it as an object, and that object we can call it the object KEGG. So we have already seen that we are using the library HGU133A and the pathway 2 pros because we are going to extract the information regarding this pathway, and we are using this command path2 probe, and after all we will get this information in the KEGG object as a list, and in the parentheses we will write the pathway 2 probe, that is the information of the data. So no matter what the annotation package is, the path2 probe is always appended to the end of the name as above. So after getting the information for the KEGG pathway, we can do the statistical analysis and we can apply the gene set test on this KEGG pathway. And for this purpose, we have to use the function or command that is global test and then parenthesis start and close. For this purpose, we have to use the certain parameters and steps to achieve this target. First is the normalized data, that is the DAT data.m. Then we need the grouping of the samples. It means that we know which one are the control samples and which one are the treated samples. And then we need to allocate the numbering to the control and treated samples. For example, we allocate 0 for all the control samples, and then we allocate the number 1 to all the treated samples. And in this way we will get the KEGG pathway information. So similarly we will use some commands. This is library global test as we have seen previously, and we allocated into the groups and allocated some numbers 0 and 1 to them. Then we will use the test KEGG, and this is the command for this one. So the results can be adjusted for multiple tests, and this function GT-MULT test does the adjustment during the Benjamini and Hochberg false discovery rate as follows, and we can use these commands to adjust these false discovery rates, and then the object test.keg contain the final result of the test. The simplest way to overview result is to print the object on the screen. So what we will get the result is, we will get the data, and it shows there are 4 samples with 22,283 genes, and they are clustered into 3 gene sets. And method is we use the all 3 permutations. So this is the final result we get after having a lot of procedures and protocols. So we can see here a lot of columns here. So the first column contains the KEGG pathway identifier, this one. The genes columns and tested column list the number of genes in each pathway and the number of genes in our list that belong to that particular pathway. So this is the total number of genes in this column, and this is the number of genes that are present in our list that are present in the pathway. So this Q test gives the observed and expected number of genes in each category. So this is the observed and this is the expected Q values in these categories. And next is the P value, and this column reports the raw P values. This is the raw P values, probability values. And the last is the FDR adjusted, and this column gives the FDR values that are P values corrected for the number test. So we will get the very detailed results, and after analysis we can get the data that are divided into different columns.